In the far reaches of our solar system, beyond the familiar shimmer of Saturn's rings and the swirling storms of Jupiter, lies a world shrouded in pale blue mystery. Uranus, seventh planet from the Sun, is a planet of extremes, tipped on its side, encircled by delicate rings and orbited by a retinue of enigmatic moons. For centuries, it kept its secrets well hidden, teasing astronomers with hints of complexity just out of reach. Now, thanks to the astonishing power of NASA's James Webb Space Telescope, we are peeling back that veil. In a discovery that has electrified the scientific community, researchers have found a new moon orbiting Uranus, one so small and faint that it has eluded even our most advanced telescopes until now. Imagine a world just 10 kilometers across, a cosmic pebble nestled close to Uranus's shimmering rings. If you could walk its circumference, you'd be finished in an afternoon. Yet this tiny body, designated S2025U1, is rewriting what we know about the outer solar system. The journey to this moment began decades ago, when a different spacecraft, Voyager 2, made history. In 1986, Voyager 2 swept within 81,000 kilometers of Uranus's cloud tops, giving humanity its first close-up view of this icy giant. With its cameras and instruments, Voyager returned a treasure trove of data, images of blue-green clouds, shadowy rings, and 11 previously unseen moons. Combined with the 5 Uranian moons already known at the time, Voyager's discoveries marked a turning point, revealing a planet far more dynamic and complex than anyone had expected. But Voyager's revelations were just the beginning. In the years that followed, astronomers equipped with the Hubble Space Telescope and powerful ground-based observatories continued the search. They spotted more of Uranus's elusive moons, some no larger than 16 kilometers in diameter. These discoveries hinted at a crowded, intricate system, with tiny satellites weaving through gaps in the planet's rings. Yet, even with these advances, S2025U1 remained invisible, hidden in plain sight, its faint glow lost against the glare of Uranus's luminous rings. Enter the James Webb Space Telescope, humanity's most sensitive eye on the cosmos. Designed to peer into the deepest recesses of space, JWST's near-infrared camera, or NIRCam, is capable of detecting galaxies billions of light-years away, and as it turns out, the faintest of moons in our own planetary backyard. During a sequence of 10 40-minute-long observations, a team led by the Southwest Research Institute trained NIRCam on Uranus, capturing detailed images of the planet, its rings, and its family of moons. Amidst the data, a subtle speck of light appeared, S/2025U1, the newest member of Uranus's lunar entourage. This discovery is more than just a numerical milestone. The newfound moon's position, nestled close to the main ring system, raises tantalizing questions. Unlike Saturn's densely packed rings, the rings of Uranus are sparse and widely separated, more like cosmic hula hoops than solid bands. Scientists have long suspected that the delicate architecture of these rings is shaped by the gravitational influence of small moons. Each miniature satellite acts as a cosmic sculptor, shepherding ring particles, maintaining gaps, and contributing to the planet's ever-changing portrait. S/2025U1, with its proximity to the rings, could be a key player in this celestial dance. But mysteries abound. What is this moon made of? Is it composed of dark, carbon-rich rock, or is it coated with ices that glint in the faint sunlight at Uranus's distance? How does its orbit interact with the rings and the larger moons nearby? Does it bear scars from ancient collisions, or has it remained untouched for billions of years? The James Webb Space Telescope may hold the answers, with its ability to analyze the colors and spectra of distant objects, revealing their composition and history. For planetary scientists, the discovery of S2025U1 is a vivid reminder of how much there is left to learn, even in our own solar system. Every new moon, every faint ring, Every unexpected feature challenges our models and compels us to look again, to refine our theories and explore further. The fact that a moon so small, so close to one of our solar system's giants, could remain hidden until now speaks to both the vastness of space and the ingenuity of modern astronomy. As we ponder the significance of this discovery, it's worth remembering that Uranus's rings and moons are not static. They are dynamic, ever-evolving, shaped by gravitational tugs, collisions, and the relentless pull of time. S/2025 U1, though minuscule by planetary standards, is a participant in this ongoing story, a story that stretches from the chaotic birth of the solar system to the bold new era of space exploration we are witnessing today. The James Webb Space Telescope's remarkable sensitivity has once again extended the boundaries of our knowledge. Peering deep into the Uranian system, Webb's NIRCam captured images so detailed that for the first time, astronomers could spot a celestial body that had eluded detection for decades, a tiny, faint moon nestled precariously close to Uranus's shimmering rings. Designated S/2025 U1, this diminutive world measures only about 10 kilometers across, so small that, as planetary scientist Heidi Hammel quipped, it's a world you could, in theory, walk around in an afternoon. To appreciate the significance of this find, consider the context. Since Voyager 2's historic flyby in 1986, when humanity's robotic emissary swept past Uranus at a distance of 81,800 kilometers, only a handful of new moons have been discovered by ground-based telescopes and the Hubble Space Telescope. Each of these discoveries pushed the limits of observational technology. But S/2025 U1 was so faint and so close to the planet's luminous rings that it remained hidden, camouflaged in the glare, just outside the reach of our previous instruments. The Webb telescope, floating in the cold darkness a million miles from Earth, changed that. Over a series of 10 40-minute exposures, Webb's NIRCam, designed to capture the faintest glimmers of the first galaxies, was turned toward Uranus. It was here, amid the complex interplay of light from distant stars, the icy planet, and its ethereal rings, that the new moon revealed itself as a faint, persistent dot. What makes S/2025 U1 especially intriguing is its proximity to Uranus's ring system. Uranus, unlike Saturn, does not boast broad, shimmering bands. Its rings are narrow, dark, and widely spaced, more like celestial hula hoops than the dense, icy disks of its gas giant cousin. These rings cluster into two main groupings, a brighter inner system and a fainter outer set. Astronomers have long suspected that the intricate structure of Uranus's rings is maintained by its moons, tiny shepherds whose gravity sculpts and shapes the rings, corralling particles into their narrow bands. With S/2025 U1 orbiting just beyond the main ring system, scientists are eager to understand its role. Is it another shepherd, guiding ring particles and maintaining the delicate architecture of the system? Or is it a captured fragment, a leftover from a primordial collision, destined to slowly spiral inward and eventually merge with the rings themselves? These questions remain tantalizingly open. The Webb images also revealed 13 of Uranus's other known moons, each a world with its own story, some only a few kilometers across, others much larger, battered and shaped by eons of impacts. The discovery of S/2025 U1 shines a light on the extraordinary diversity and dynamism of the Uranian system. What do we know so far about this new satellite? Its color and composition remain mysteries. Is it composed of ice, like many of Uranus's moons, or is it a darker, rockier body? Webb's powerful instruments may soon be able to provide spectral data, allowing scientists to analyze the light reflected from its surface and infer its composition. These observations could reveal whether S/2025 U1 shares a common origin with Uranus's other moons, or if it was captured from elsewhere in the solar system. Such discoveries underscore a profound truth. Even in our own celestial backyard, the solar system still harbors secrets. Every new moon, every faint ring, and every subtle gravitational interaction adds another piece to the grand puzzle of planetary formation and evolution. S/2025 U1 is more than just a tiny distant rock. It's a new data point that will help refine our models and challenge our understanding of how moons and rings coexist and evolve. The ongoing hunt for small moons and ring fragments around Uranus is not merely an academic exercise. These objects are cosmic laboratories offering clues about the early solar system. The rings themselves may be the remnants of shattered moons, ground down over time by countless collisions. Each moon, in turn, may influence the ring's structure, sweeping up debris, opening gaps, or shepherding particles along narrow paths. The dance of gravity and motion, of collision and coalescence, is written into every orbit and every shadowy crescent. Webb's discovery also highlights the extraordinary synergy between space-based observatories and planetary science. Designed to peer back in time and study the birth of galaxies, the telescope is also revolutionizing our understanding of objects much closer to home. The ability to resolve faint, small bodies near the overwhelming brightness of a giant planet is a testament to the sophistication of modern astronomical instruments. This is just the beginning. With every new observation, the Webb telescope will continue to probe the Uranian system, capturing images and spectra that may reveal not only more moons, but also changes in the rings, atmospheric phenomena on the planet, and perhaps even signs of seasonal activity as Uranus slowly completes its 84-year orbit around the Sun. As scientists analyze the data, they are also refining their search techniques, learning how best to tease faint signals from the background glare and how to distinguish true moons from transient clumps of ring material. The next discoveries may be just around the corner, waiting in the data archives, hidden in the shadows, or orbiting quietly in the darkness beyond the rings. In the grand story of the solar system, the discovery of S/2025 U1 is a reminder of the richness and vitality of planetary science. Each new moon is an invitation, a challenge to look deeper, to ask new questions, and to marvel at the dynamic, evolving systems that orbit far beyond our home planet. As the James Webb Space Telescope continues its mission, who knows what other wonders await, concealed in the darkness, ready to be revealed by the patient eye of science. The discovery of S/2025 U1, the tiny new moon of Uranus, is more than just another point of light cataloged in our solar system. It's a demonstration of how far our tools and techniques have come, and how even in the well-trodden territory of our own planetary neighborhood, surprises still await. The James Webb Space Telescope, engineered to detect the faintest galaxies across the vast cosmos, has now shown its prowess much closer to home. With its near-infrared camera, JWST was able to tease out this delicate, almost ghostly object just 10 kilometers wide from the planet's glaring rings and the luminous haze surrounding Uranus. This is a triumph not just of engineering, but of timing and tenacity. The research team from the Southwest Research Institute conducted a series of 10 40-minute exposures, capturing and stacking data to enhance the faint signal of the new moon, S/2025 U1. While Voyager 2 opened the door in 1986, giving us our first close-up of Uranus and unveiling a host of previously unknown moons, JWST has now peered even deeper, refining our image of the planet's retinue. What's particularly intriguing about S/2025 U1 is its position, nestled close to Uranus's main ring system. Unlike the dense, uniform bands that encircle Saturn, Uranus's rings are thin and widely separated, almost like a set of cosmic hula hoops. Scientists have long speculated that these rings are sculpted and maintained by the gravitational influence of small moons, called shepherd moons, which herd the ring particles into their sharply defined edges. The discovery of S/2025 U1, so close to the rings, raises immediate questions. Is this moon currently shaping the rings around it? Could its gravity be responsible for subtle features or gaps detected in the ring system? Or is it perhaps a remnant from a long-ago collision, its presence a clue to the violent history of Uranus's formation. With JWST's sensitive instruments at the ready, astronomers hope to answer these questions and more. By analyzing the moon's color and composition, they can begin to determine whether it shares a common origin with the other moons, or if it's a captured object, perhaps a stray from the outer reaches of the solar system. Spectroscopic measurements could reveal the presence of water ice, rock, or organic materials, offering hints about the environment in which S2025U1 was born. Each data point adds a pixel to the evolving portrait of Uranus, its rings, family of moons. And yet, this is only the beginning. If a moon just 6 miles across could remain hidden for decades, what else might be lurking near the glare of bright planets or within the shadows of their rings? As JWST continues its mission, and as new observatories come online in the years ahead, we can expect the census of our solar system's moons to grow. Each discovery not only extends our knowledge of planetary systems, but also helps us understand how rings, moons, and planets interact, a dance of gravity and matter that has shaped the solar system for billions of years. The pace of discovery in planetary science has accelerated dramatically. In just the last few decades, missions like Juno have rewritten the textbooks on Jupiter, revealing new insights into its colossal storms, its deep atmosphere, and its own collection of moons. Now, with JWST's gaze turned toward the cold, distant giants of the solar system, Uranus and Neptune are finally coming into focus. The faint, icy worlds at the edge of our solar system are yielding their secrets, one by one. It's a vivid reminder that the solar system is not a static, unchanging place. Rather, it is alive with motion, with collisions and accretions, with the subtle interplay of forces that sculpt rings and assemble moons. Even now, as we map the orbits of newly discovered satellites, model their interactions, and trace the history of their parent planets, we're uncovering the ongoing story of creation and change that defines our corner of the universe. The discovery of S2025U1 also highlights a fundamental truth of astronomy. The universe is full of surprises. As technology advances and our instruments become more sensitive, objects that once seemed invisible are brought within reach. The tiniest moons, the faintest rings, the most elusive phenomena, they are all waiting to be found, just beyond the limits of our current perception. Every discovery, no matter how small, has the potential to reshape our understanding. S/2025 U1 is a testament to the curiosity and perseverance of scientists and to the power of international collaboration in pushing the boundaries of knowledge. From the engineers who built JWST, to the astronomers who designed its observations, to the analysts who pored over the data, each played a part in adding a new chapter to the story of Uranus. Looking ahead, the questions multiply. Will JWST or future telescopes reveal even more hidden moons? Will we finally unravel the mysteries of Uranus's tilted axis and its dramatic seasons? Can we connect the dots between the ice giants and the exoplanets now being discovered around distant stars, some of which might be Uranus-like worlds, encircled by their own rings and moons? With every new observation, we edge closer to answering these questions. The cosmos rewards persistence and ingenuity, and there is so much more to uncover. For now, S2025U1 stands as a beacon, a tiny, icy wanderer circling Uranus, a marker of how much we have learned and how much still lies ahead. If you enjoyed this journey into the latest discoveries at the edge of our solar system, make sure to like this video and subscribe for more content like this. The universe is always unveiling new wonders, and together, we'll keep exploring them.